Here we're going to look at an interactive simulation for a semi-batch reactor. It's run isothermally. Two reactions. We're interested in making the desired product as opposed to the undesired product. And the reason for running semi-batch in this case is because the desired product is first order in the concentration of A and second order in the concentration of B, whereas the undesired product is first order in the concentrations of both A and B. And so if we want to maximize selectivity, in this case we're talking about selectivity as the number of moles of D at any given time over the number of moles of U. If we want to maximize that, we want to keep the concentration of B high because that keeps the rate of this high relative to this rate. And this means we'd want to run the reactor by starting with B in the reactor and then adding a flow rate of A, and the simulation is set up so if we start with some initial moles of B, we continue to add A until the amount of A that we added, so total moles of A added, not the number of moles in the reactor, is the same as the number of moles of B that we started with. Now, the selectivity also depends on the relative activation energies. So we increase the activation energy for, say, this undesired reaction. That means if we raise the temperature, the rate of that undesired reaction increases faster than the rate of the desired reaction. And we have the option of plotting number of moles of desired and undesired products or number of moles of reactants as a function of time or selectivity. So we'll look at the actual simulation to better understand the behavior. So here's the simulation. We're adding A to B. Let's look at selectivity plots. So the selectivity starts out fairly high, 9 in this case, and then it decreases because we're decreasing the concentration of B as reaction proceeds. If we were to look at the concentrations of reactants, of course concentration of B is high initially, A is low, and then as we add A and of course use up B, and the rates slow down, go through a maximum in the concentration or number of moles in the reactor, and then they both decrease with time. If I go back and look at selectivity, and so if I were to increase the activation energy of the undesired reaction, notice the selectivity goes up because I've essentially decreased the rate of that reaction. However, as I raise the temperature, now the selectivity goes down because we start to preferentially increase the rate of that undesired reaction. So if instead I add B to A, that's not the desired way to run the reaction. So you'll notice that initially selectivity is very low because we have almost no B. And so we're not favoring the first reaction, we're favoring the undesired second reaction. Selectivity increases because we're increasing the concentration of B in the reactor. But notice the value is still much smaller than the selectivity if we add A to B.